Hey guys, we're going to start out lesson 4 from chapter 4. We're going to start with factoring, things that are a little bit trickier, and but we're not going to be really introducing anything new. We're working on difference of squares and seeing where that takes us. So the first thing I want to do is just remind you what a difference of squares looks like. If I have two binomials, if I have 2x plus 5y, and I multiply that by 2x minus 5y. So we see that the binomials are quite similar. The only thing that is different is the sign on one of those terms. So if I multiply this and I FOIL it, right, firsts and then outside, so I have 4x squared minus 10xy. And then I do my insides and outsides, and I get plus 10xy minus 25y squared. We can see that these two middle terms actually cancel out really nicely. And we get 4x squared minus 25y squared. So let's look at a couple of these properties. One, both terms are squares. So that is a requirement. Both terms must be squares. The second thing is that we have a difference. So if we are adding two squares, that is not called a difference of squares. They must be subtracted. So let's try some examples. Again, this is not new. Many of you are rolling your eyes at this point. So let's factor. Here we have number 1a, so I can see that 9x squared, that's a square, 9's a square, x squared is a square. Negative 16y squared, 16y squared, that's a square. So I can just go straight into this, and I can say 9x squared square rooted is 3x. I can put those two there. And 16y squared square rooted is 4y. That's nice. And then a plus and a minus. That's it. We're done. Now what's the problem with b? b is a problem because 3x cubed y is not a square. We can't factor it the way we've factored things before, plus we have two variables and a whole bunch of different kinds of exponents. Oh no, what can we do? So looking back to the things that we should be doing when we factor, I'm just going to scroll back up here. Number 1, always look for a common factor. So, hey, we have a common factor here. We have 3 as a common factor. Both of these terms have x's, and both of these terms have y's. So I can factor that out. What multiplies 3xy to get 3x cubed y? Well, x squared. If we multiply those two together, we get this, right? So now I can subtract, 3 times 9 y squared. Super. So we have 3xy. That doesn't go anywhere. That is still one of my factors. The other factor I have here is the difference of squares. So I can say x and x. That gets x squared, right? And I have 3y. 3y, 3y. So I can add and subtract. That's done. Fully factored. Super duper. Sometimes we're fooled and we think that we can go straight to a difference of squares because they are both squares. And this is an example where maybe we're going to miss one of those common factors. So 4 is in fact a factor of 144. So 144 is 12 times 12, so 4 times 36. So I can actually factor out the 4 first, get 36 p squared q squared minus r squared. And that's what happens. Because this is in fact already a square, we might forget that we can actually factor that as a difference of squares. So I'm going to have 4, 36, we can factor this. These are both still squares. If you factor a square out of a square, it'll still be a square. 6pq, 6pq, r plus minus. And it doesn't matter the order of the plus or minus. You can switch those around if you want, if you're adventurous. Can Can I move this? Wow, magic. All right, so now let's factor completely. Why don't you give these a try? You can hit pause on the video and give these a try. All right, so if we factor this, I can see that k exponent 4 is k squared times k squared, so it's k squared squared, right? K squared squared minus 1, which is also a square. So I could say k squared plus 1 times k squared minus 1. Hey, that's great, but we're not done yet. If we go way back up here, number 6 is restart, look for more factoring. Okay, if we look for more factoring, it might be there. And we can see that, oh, we do have another difference of squares. So sometimes they happen more than once. And k plus 1, k minus 1. I'd like you to see if you can try to factor that, if there's anything that can multiply to get k squared plus 1, because I've never been able to find one. So anyway, you can try that. B, you can give that a shot, and C as well. I'm going to go ahead and do those. So pause, and you can find out what's there. Okay, I'm going to factor out the 5. So I have 5 times 16a to the 4 minus x to the 4. 5, 4a squared plus x squared. 4a squared minus x squared. And 5, 4a squared plus x squared. And of course, we have another difference of squares. So these get pretty big quite quickly, 2a minus x. So we count to the factors. We have 1, 2, 3, 4 factors to get these two terms, which is pretty remarkable. I'll let you try the last one there on your own. If you have any questions on it, you go for it. Next, example 4, we have two terms. These brackets here mean that we have a single term. We're grouping these as B and C, but we're squaring it to turn it into a single term. But I do recognize that this is a square and this is a square because of that exponent. So I can say a plus, a minus, and what's the square root of b minus c squared? Well, that's just b minus c in brackets, and b minus c in brackets. Now, why do those brackets matter? They don't really change much in the first factor, so I'm still just going to have a plus b minus c. In the second factor, though, a minus b, we have to remember this, right? So we have to remember to apply that negative to the negative c. So we get plus c. Oh, I can do that in black. That should be in black. Aesthetics. And that's it. So if we multiply these out, and let's try, you can see what it looks like if it's not already in this other form. So we can say a times a. I like to see what this looks like. So I'm going to say a times a, right? This is our answer up here, but let's check our answer. A times a is a squared minus ab plus ac plus ab minus b squared plus bc minus ac plus bc minus c squared. So let's look to see. Let's find out if we can actually cancel any of these. So ab, those are gone. ac, those are gone. And then we have these guys right here. Can we factor that? Can we factor that? We've got the a squared. That checks out, right? A squared, done. Let's go back to red. So I have a squared. Let's just clean this up a little bit. Minus b squared plus bc, or 2bc minus c squared. I'm going to factor out the negative. I'm going to factor out the negative here. A squared minus b squared minus 2bc plus c squared. Does everyone see why I was able to factor out the negative out of each one? If I multiply a negative 1 back in, I get those three terms again. Now I have a squared minus, well, b squared, c squared. What multiplies to get 1 and adds to get negative 2. Well, that's negative 1. So I have b minus c, or minus 1c squared. That's it. So we do actually get that first one. And this next one, I'll let you try that out. I think it's kind of fun. Why don't you try that and then join me back again when you're done. Okay, so let's take 2x minus y and x plus y. We see that they're both squared, and this is a difference of squares. So we can go ahead with our regular, double big brackets here. 2x minus y, 2x minus y. And I'm not going to put brackets around it anymore. I've kind of used up those brackets because it's not being multiplied by anything. Then I'm going to put plus and minus. Now I'm going to put brackets because this is being multiplied by possibly a negative one here. So I can put an x plus y and an x plus y. Now let's add up our like terms. This is a little bit different than the ones we've done before. We haven't really had any like terms before. So 2x plus x, we can see that these are like terms as they are here. And we have other like terms, the y's, that we can put together. So let's continue with those. 2x plus x is 3x. Negative y plus y is gone. So that's it. 3x is one of my factors. Now, 2x minus x. What's that? 2x minus x. That's an x. And negative y minus y is minus 2y. That's it. I can't see any more factoring that can be done. So that's it. So in today's lesson, we looked at how to factor difference of squares when those terms are not typical simple monomials or simple squares. Remember to look for a common factor. Remember to always look for more factoring when you think you might be done. Add up like terms inside your factors if possible. Make sure you get lots of practice, and there'll be an assignment posted probably tomorrow, and I hope you're ready for it. All right, bye-bye.